All right, so at this point, we are solving more complex radical equations. Okay, so this is lesson number 7. Now, Billy was given the radical equation, square root of 3a plus 4 minus the square root of a plus 1, and that's equal to 3. Billy solved the equation incorrectly, so his work is shown here. Now, the first thing we need to do is explain where Billy made his error. So 3a plus 4 minus a plus 1 is equal to 3, and those are both rads. So he wrote that out, okay, so that's right. Now let's see, 3a plus 4 is equal to 3, so what he did, plus a plus 1, so what he did was he brought this term over to this side, so he subtracted both sides by a plus 1, and he subtracted this side by a plus 1, and he did that in order to isolate this radical, and that is also correct, right? You can do that. And then let's see what he did. He squared both sides in order to get rid of the radical sign here and this radical sign here, and that is also correct. That's allowed. Now let's see what happened. He got rid of the radical sign, and he's left with 3a plus 4, which is good. And he got rid of this radical sign, a plus 1. But when he squared it, this is where he made the mistake. Is if you're squaring this whole term here, he's forgetting the middle expression, right? Because 3a, what this looks like is 3 plus a plus 1 times 3 plus a plus 1. And this is remember, this is a perfect square. This will be a perfect square trinomial, right? And so we could say that 1, 2, 3. You say that Billy made his mistake. Billy made his mistake in step 3. In step 3. And he did not expand the right side of his equation properly. Okay, so now we need to show the correct work. So we're starting out with our equation, the square root of 3a plus 4 minus a plus 1, and that is equal to 3. Alright, and so we're going to start the exact same way that Billy did. We're going to get this, we're going to isolate one of these radical expressions here. And so we're going to add a plus 1 to both sides. Add a plus 1, and we're going to add a plus 1. Oh, I made a mistake at the top here. I don't know if you caught that, but I said he subtracted by a plus 1 on both sides, but he added, which was good, because that's what we're doing now. Okay, so he added the square root of a plus 1 to both sides, and so then he's left with rad 3a plus 4 is equal to 3 plus rad a plus 1. And now the next thing he did was he squared both sides. Or he squared both sides. So 3a plus 4. Oh, someone's knocking on my door. I'm going to pause. Sorry, I'm back. That was just a minor interruption. Okay, so we have to square both sides, and so we need to square this side as well. 3 plus a plus 1, and we're going to square that. And so we're going to be left with 3a plus 4. But now, if we're squaring this side, remember that if we have a perfect square binomial, then we square this term, so 3 squared will be 9, but then the middle term, we have to multiply the middle term, so 3 times rad a plus 1 would be 3 rad a plus 1, then we multiply it by 2, which would give us 6 rad plus 1. Okay? So I'm going to be left with 9 plus 3 times a plus 1 is going to be 3a plus 1. And then I got to times this by 2 since I'm squaring it. So I'll be left with 6 rad a plus 1. And then I'm going to be left with a plus 1. Okay, so that's the step that Billy here didn't do correctly. Alright, and so the next thing we need to do is we need to kind of balance out our equation. Alright, and so what I'm going to do is I'm going to bring this a plus 1 over the other side. And so I'm going to go minus a. And then what we're also going to be doing is going to be minus a, and then we're going to minus 1. But I'll do this one at a time. So minus 1. So if I subtract a from here, I'll be left with 2a plus 4 is equal to 9 plus 6 plus 1. Plus 1, right? Now, I can gather my like terms here and here, so then I have 2 plus 4 is equal to 10 plus 6 a plus 1. Now I'm going to get rid of this 10 on this side, and so I'm going to subtract this 10 on both sides. So now I'll be left with 2a. Negative 10 plus 4 will be negative 6, and I'll be left with 6 a plus 1. Okay, and so now what we need to do is we need to break down this radical term here, 6 rad a plus 1. Now in order to do this, I am going to square both sides again. Okay? And so if I square both sides, we have 2a minus 6 squared is equal to 6a plus 1 squared. And on this side, notice what you have here. You have this is a perfect square. Right? And so with a perfect square, we're going to have, oh, sorry, that's not a perfect square. Nope, sorry, what am I saying? Anyways, if we expand this, we're gonna have 4a squared minus 24a, since what we're doing here is 2a minus 6, 2a minus 6. Right, so that's where my 4a squared comes from. Minus 6a times 2a is 12a, minus another 12a will be my negative 24a, plus 36, because negative 6 times negative 6. And on this side equation, we're going to be left with 6 squared is 36, 36, and then a plus 1, which is the same thing. 46a, 24a, plus 36. I didn't change anything over here, but over here this is going to become 36. If I multiply, 36a plus 36. Okay, now I can set this equal to 0. And you're like, holy, why is this equation so long? But don't worry, it's well, actually there's no way around it. It's just going to be a long equation. Okay, so now what we need to do is we need to set everything equal to 0. So I'm going to bring this over to my other side of my equation. So first I'm going to subtract 36a, which would leave me with 4a squared minus 60a plus 36 is equal to 36. Now I got to get rid of this 36 here. So subtract 36 on both sides. 36 minus 36 will be 0, so I'm left with 4a squared minus 60a is equal to 0. And now we need to factor this. But before I factor this, I know that both these terms are divisible by 4. And so if I divide the 4 out of here, the 4a, I'll have 4a, a times a would be, 4a times a would be 4a squared, minus 15 is equal to 0. And so reach back to lesson number 5 where we talked about our product of zero law, or our zero product law, and that tells us that one of our products needs to be equal to 0. So A is equal to 0, but A is also equal to, if we solve this algebraically, is going to be positive 15. By now you should just be able to recognize what that's going to be, but it's going to be A is equal to 15. Now let's verify which one of these solutions it is going to be. Okay, is it going to be A is equal to 0 or A is equal to 15? Now let's verify A is equal to 0. Okay, so the left side is equal to 3 times 0 plus 4 minus 0 plus 1 is equal to 3. Oh, sorry, we're just doing the left side right now. Okay, so let's forget this plus 3 here. So this is 3 times 0 is 0, so that's 4 minus square root of 1, and that's equal to 2 minus 1, and that is equal to 1. Now the right side of the equation is 3. 1 does not equal 3. The left side is equal to 1, and the right side is equal to 3. So it cannot be 0. Okay, so let's scratch that. Now let's verify A equals 15. Okay, so the left side is 3 times 15 plus 4 minus 15 plus 1, and that, remember, needs to equal 3. So 3 plus 15 plus 4 is going to be 42 plus 4 is going to be 45 plus 4 is 49 minus square root of 16. That's going to be 7 minus 4, and that is equal to 3. Our right side equals 3. Left side equals right side, because 3 is equal to 3. Therefore, it works, and there's our solution. A is equal to 15. Okay, so let's look at this next question. When the square root of 2 less than a number is subtracted from the square root of 5 more than twice a number, the result is 3. What? Are you serious? Okay, so if you're looking at something like this, you're like, what? Where do I start? Okay, so the first thing you need to do is just read it very slowly, okay? So when the square root of 2 less than a number is subtracted, so we're told that this number here is going to be subtracted, okay? So we're subtracting whatever this is, and it's the square root, so we're subtracting the square root of 2 less than a number, okay? We don't know what this is. What is that number? So that's going to be called x, and we're taking the square root of 2 less than this number. Okay, so it's going to be x minus 2. That's what this is. Square root of x minus 2. And we're subtracting it from the square root. So this is what's going to be on this side of my equation here. Over here is going to be whatever this is. It's subtracted from the square root of 5 more than twice a number. Okay, so again, this is a square root, and we're subtracting it from the square root of 5 more, okay, than twice the number. So that number is x, we don't know what it is, and it's 5 more than that number. So 2x plus 5 minus x minus 2. And the result of doing that is going to give us 3. Okay, so that is the result. Now we need to solve this to determine what the number of x is. Okay, so we're just doing this algebraically. Now, remember, the first step is, if this is what we're solving, the first step is to balance this out. Okay, so in order to do this, we need to isolate one of our radical terms. And so I'm going to add this term over here. So that's going to give me 3 plus x minus 2, square root of x minus 2. And I'm going to square both sides. Okay, so if I square this side, I'll be left with 2x plus 5. And if I square this side, remember, if I square this is going to be 3 plus x minus 2 and 3 plus square root of x minus 2. And so if I square that, that'll be 9 plus 3 times that is going to be 3x minus 2 squared, or times 2 is going to be 6x minus 2 plus x minus 2, since those brackets will cancel out. Okay, and so now what we need to do is let's gather all our like terms, but before we do that, we need to isolate this term here. Okay, so I'm going to subtract 9 from both, or first let's gather this. So 9 minus 2 is 7, right? So 2x plus 5 is equal to 7, because I'm gathering these two terms, plus 6x minus 2 plus x. I'm going to bring this x over here, so that's just going to be x. I'm going to subtract 7 over here, so this will be x minus 2 is equal to 6x minus 2. There we go. Okay, so that's what I'm going to be left with now. So I encourage you to pause the video here and just think about how I got from here to here, or even from here to here. Okay? Now, I need to get rid of this radical sign here. So I'm going to take the square root of both of these. Or not the square root, I'm going to square both of them. X minus 2 squared is equal to 6 rad x minus 2 squared. Okay, so remember that this is x minus 2, and so that's going to be x squared, negative 2, and negative 2 is going to be negative 4x plus 4. And that's going to be equal to 36 times x minus 2, right? 36x minus 2. Now, from here we have to, I'll expand that second term, is equal to 36x minus 72. Okay, I just multiplied that, and I multiplied that. Okay, and so now we can set this equal to 0. Okay, so if we do that, x squared, if I take 36x over here, negative 36x minus 4x is going to be negative 40x. And if I add 72 over here, I'll have positive 76 is equal to 0. Alright, so let's think about what two terms are we going to have. If we have to have a product of 76 and a sum of negative 40. Okay, so let's think of these numbers. Let's go 76 divided by 2 is 38. 38 plus 2 is going to be 40. Good. See, those are our numbers. Alright, and so it has to be negative 38 and negative 2. Okay, so that's going to be x minus 2, x minus 38, and that equals 0. So our solutions are going to be x is equal to 2 and 38. Now remember, from here you have to verify. And your quiz question is to tell me which of these is the real solution. Okay? Which is the solution? This is your quiz question. Important. I'm going to ask you this in class. Alright, if you tell me the correct answer, you will get a mark. That is it.